So in the last video we talked about the triangle law. So in this video I'll be talking about the parallelogram law. So I'll take the same two forces I drew when I introduced what is meant by triangle law. So this is parallelogram law. So I'll use the parallelogram law. So I'll use the same two forces I used when I introduced the concept of triangle law. So I'll take a force like this F1, I'll take another force, inclined force like this F2. What is it? This is equal to 60, right? This is equal to 60, F1 and F2. So what's the resultant of these two forces? Now you know how to calculate the resultant of these two forces if you have watched my video. So if you have not watched this video, I invite you to watch that video and come back here and watch this video, because actually I told you in the last video as well, parallelogram and triangle law act simultaneously. That means there's a complete relationship between parallelogram law and triangle law and vice versa. So parallelogram law is connected to the triangle law, and you can derive triangle law from parallelogram law. Alright, so there's a connection between parallelogram law and triangle law. So you know how to find the resultant of these two forces from the triangular theorem. Now I'm going to introduce how we can find the resultant of these two forces from the parallelogram theorem. So first of all, before finding the two forces using the parallelogram theorem, there's a special equation, actually two equations. One equation to find the resultant of two or more forces, actually two forces. And the other thing is how to find the angle that the resultant makes with the horizontal. So first of all, before finding the solution for this using the parallelogram law, I will derive those two equations. So if I take a force like this F1 and another force F2 here, which is theta degrees inclined to the horizontal, right? Which is theta degrees inclined to the horizontal, F1 and F2. So what I will do is that I will now place the head of the first vector on the tail of the second vector. Head of the first vector, like this, like what you call triangle law. This is the head of the, because this is directing this direction. This is actually the head of the first vector. So this is directing this direction. So this will be the tail of the second vector. I will place the head of the first vector. Now this point on this point. This point on this point, right? Head of the first vector on the tail of the second vector, or simply tail of the second vector on the head of the first vector. Alright, so what happens here is that this is F1, this is F2, so this will be theta. And now you know that the resultant from the triangle law, as I told you that the parallelogram law and triangle law are always interrelated. So I will now, the resultant of these two forces will be such that the tail of the first vector and the second head of the second vector are connected by an arrow. This will be Fr, right? This will be Fr. So what I'll actually do is that I'll construct a parallelogram here. Now I have one side, this one like this. So what I'll do is I'll draw a parallel line that goes through this point, and that is parallel to F1. So this is a parallel line here. Right? This is a parallel line here. And I will also construct a parallel line that goes through this point and which is parallel to this side. Right? Now this is actually, now this side is parallel to this side, and this side, length of this side should be equal to the length of this dotted side, right? Length of this dotted side, and length of this side should be equal to the length of this dotted side, which is inclined, and these are parallel. So this is actually a parallelogram, and this, so the F1 is not equal to F2, so this can't be a rhombus. So since F1 is not equal to F2, this is not a rhombus. So if theta is not equal to 90, this can't be a rectangle as well. So this is only a parallelogram. So this is what I am actually doing, is I am constructing a parallelogram and then finding the resultant of the two forces. So okay, so this is parallelogram law. So how can you find the resultant of these two forces? So what I will do is I will construct a perpendicular from here to here, right? I will construct a perpendicular from here to here, So that FR is now FR this triangle, right? This triangle which is more bordered with some as great width, right? This triangle, right? I take it as ABC, and this is D. So that ADC, right? ADC is a right angle triangle. So this is a right angle triangle here, right? ADC is a right angle triangle, right? So what happens is that now if this is F2, right? This is F2, right? This is F2. So if this is F2, this length should be BD should be F2 cos theta. And this is F2 and this is theta. CD, so CD is this length, which is one side of the right angle triangle, should be, so if this is F2 and this is theta, CD should be F2 sin theta. So this should be F2 sin theta. So if this is F1, right, this is F1 and this is F2 cos theta. So F2 cos theta, when you are decomposing this side, so F2 cos theta will be in this direction and F2 sin theta will be in this direction, right? If F2 cos theta in this direction and F2 sin theta in this direction. So F1 and F2 are in the same direction, so they will add up, so that I can write the new triangle, I can construct a new right angle triangle based upon the data I have already gathered. So this will be like this, right? This will be like this, new right angle triangle. So this is now F1 plus F2 cos theta, right? F1 plus F2 cos theta, and this will be now F2 sin theta. Right? So from the triangle law, the resultant of these two forces will be this side, FR, which is also the hypotenuse. So you can now put the Pythagoras theorem. Alright? So you can put the Pythagoras theorem to this triangle. So this is a triangle, I will draw it again because this is on another paper. Right? This is F1 plus F2 cos theta. And this is F2 sin theta, and this is F1, right? This is FR. So I will take this, I have taken this side as triangle as ADC. Here is A, here is B, here is C. ADC triangle. For the ADC triangle, this angle is 90 now, right? So I can put the Pythagoras theorem to this triangle. So Pythagoras theorem, from Pythagoras theorem we can say FR square is equal to F1 plus F2 cos theta square, F1 plus F2 cos theta holding square plus F2 sin theta holding square, right? So here is FR square, so I can simplify this. So F1 plus F2 cos theta square, so this is like A plus B squared, so it will be A squared plus B squared plus 2 times AB. So A squared is F1 square plus B squared will be no, I'll take simply 2 times AB first. So 2 times A is for F1, B is F2 cos theta, so it will be 2 times F1 times F2 cos theta. So that will be 2 times F1 F2 cos theta. F2 cos theta, and B square is equal to F2 cos theta square, so that will be F2 squared cos squared theta. F2 cos square theta, right? Cos square theta plus f2 sin theta squared here, f2 sin theta squared here plus f2 sin theta squared, so it will be f2 square sin square theta, right? f2 square sin square theta. So here it will be f1 squared 2f1 plus f1 f2 cos theta, right? f1 squared 2f1 f2 cos theta plus I'll take f2 squared here out, so it will be f2 squared out, so it will be sin square theta plus cos square theta, right? So sin square theta plus cos square theta is equal to 1 from trigonometric relation. So if you are not well versed with trigonometry, I invite you to watch my video and come back here. So sin square theta plus cos square theta is equal to 1. So this is f2 squared. You have f2 squared here, so f2 squared will be multiplied by 1, so it is f2 squared. You have f1 squared here, so I will add up those two. So fr squared will be, right? Fr squared will be f1 squared plus f2 squared plus 2 times f1 times f2 times cos 2, right? So we don't normally find the values f1 and f2, so it's easy f1 and f2. We just, what we do is we substitute r equals fr, f1 p equals f1 and q equals f2. So these are just substitutions, so that it will be easy to write. Now we write f1, f2, we have to solve that, so it takes a lot of time. So what we actually do is we just substitute some other values. So the resultant force is R. Now from here onwards I will use R for the resultant force, not FR. Not in this video, for the videos coming back after this on this will. So R is equal to FR, P is equal to F1, Q is equal to F2. So this is, I can substitute these values here. So R squared will be equal to P squared plus Q squared plus 2PQ plus T. Right? R squared will be equal to P squared plus Q squared plus 2PQ cos theta. So R will be equal to the root of the right hand side to the power half or root. So that's R. So what is the angle? So I also talked to you about I mentioned what is the angle between the resultant force and the horizontal. So I'll take the same paper like that, right? The previous note. So this angle theta is not the angle, because this angle is not, no, this is the angle I'm talking about, right? This is the angle I'm talking about. I'll take it as alpha. So alpha is not equal to theta, because FR is not parallel to F2 here, right? FR is not parallel to F2, so there will be some angle alpha. So to find alpha, so this alpha is actually equal to this angle, right? Alpha is equal to this angle, the angle how FR makes, the angle between the FR and the horizontal. So this is alpha. Now to find alpha from the ADC triangle, what we have to do is we can take the tan ratio, the tan or the ratio of these two, and then take the tan inverse of the arctan. So you can say tan alpha is equal to, so this is, I write f2 sin theta divided by tan alpha is equal to f2 sin theta divided by f1 plus f2 cos theta. Right? So f1 and f2 cos theta, the addition is so that it will be not equal to 0, so that tan alpha equals 1 upon 0 is not defined. And so I have already used that f1 is P is equal to f1 here, P is equal to f1 and Q is equal to f2, so I substitute here as well. So tan alpha is equal to f2 is Q sin theta divided by P plus Q cos theta. Right? Tan alpha is equal to Q sin theta divided by P plus Q cos theta. So what is important is actually here also not the solution to this problem, what is important here is how we can put the parallelogram law if given some two forces. So if you given some two forces in the parallelogram, what you have to do is the same, that you construct the triangle and then put the parallelogram law. So in some sums, so you will also get an opportunity like this. In which the two forces are not in the direction that I have already told you. So like this. Right? So if the two forces are like this, what happens? So F1, I'll take as P, right? I'll take as P, and the forces are Q. So these are actually the normal. This is P and Q. So this is equal to some angle theta. I'll take. I should counterclockwise or anti-clockwise. So this is the normal distribution, normal derivation of the parallelogram law. So what you will find here is this one. So you can put the parallelogram this way as well. If you put the tail of the second vector on the tail of the first vector, so the like this position like this. So this will be P, this will be Q, this angle will be theta, right? A position like this, the tail of the second vector on the tail of the first vector, then the resultant is given by the resultant's tail will coincide with the head of the second vector, and the resultant's head will coincide with the head of the first vector, like this. Like this, right? So this is also called the parallelogram law. So there are various methods you can draw the parallelogram law. So parallelogram law is not limited like the triangle law. Triangle law you can draw like that. So the parallelogram law is not limited like that. So the only thing is you have to construct a parallelogram and then you can find using the equation. So if you have some two forces like 6 and say we have forces 6 in this direction, 10 in this direction, and this angle is 30. No, this angle I take 150. Right? So this is 10, this is 6, and this is 150. So you need to find what is this force, Fr. Right? You need to find what is Fr. So now you know from this angle, the P, I'll take P equals 6 and Q equals 10. It doesn't matter, right? Either P is 6 or Q is 10 or Q is 6 and P is 10. I'll take like this. And theta is equal to 150. So theta is the angle between P and Q, whether it's obtuse, acute or right angle. So theta is the angle between P and Q. So I can find Fr over R. Fr equals R here. So R is equal to, right? R is equal to, R square is equal to P squared plus Q squared plus 2PQ cos theta. Right? Cos theta. So P squared is equal to 6 squared plus Q is equal to 10, so that's square, 10 squared plus 2 times P is equal to 6 and Q is equal to 10, so this is cos 150. Right? Cos 150. So this is 36 and this is 100, so this is 136. So 136 and cos 150 is equal to minus cos 30, so minus cos 30 is equal to minus root 3 by 2. So that multiplied by this one is equal to minus root 3 times 6 times 10, that is equal to minus 60 root 3. Right? Minus 60 root 3. Right? So this you can find R from this one. So if you find alpha is equal to tan inverse. So alpha is this angle, it makes it the horizontal. Right, alpha is this angle. So alpha is equal to tan inverse q sin theta. So q sin theta, q is equal to 10 sin 150 divided by p plus q cos theta. So p is equal to 6, q is equal to 10 cos theta cos 150. So sin 150 is equal to sin 30 plus sin 30. So plus sin 30 is equal to half. So 10 times half is 5 here. Divided by cos 150 is minus root 3 by 2. That multiplied by 10 is minus 5 root 3. So this will be 6 minus 5 root 3. So it will be 5 divided by 6 minus 5 root 3. Right? 6 minus 5 root 3. So that's the angle of alpha. So that's just a simple calculation in which the parallelogram applies. So in the next video, we talk about how the parallelogram is so much important in identifying the behavior of forces when they act in such a manner. So thanks for watching this video and see you next time.